So, hello and welcome to the Dragonfly Daily. I am your host, Mike, the product manager for Dragonfly at ORS. Welcome to today's lesson. This is lesson 9, ROI Painter. So this is the second of a third-part series for lessons 8, 9, and 10 that are specifically dedicated to image segmentation in Dragonfly. So yesterday in lesson 8, we did look at the ROI tools for creating ROIs. We looked at some thresholding and some other operations. We're going to pick up today and talk about ROI Painter, which allows you to do manual curation and editing of segmentations, which can be very powerful and is often required with more demanding segmentation tasks, particularly in biological samples. But you'll see that it gives you a lot of freedom even in non-biological samples. And then in lesson 10, we will turn to some more advanced techniques. We'll put together some of the things we saw in lessons 8 and 9 and some other new features that we haven't seen yet. If you're watching this on YouTube, hit the subscribe button now and go ahead and give us a like so we know that you like the content on this video. So, Lesson 9, ROI Painter, we are using Dragonfly 4.1, and in Lesson 6, we did customize the user interface a little bit. So Lesson 9, yes, today's Thursday. Yeah, great, Lesson 9. And so we are using Dragonfly 4.1, but we have done a little bit of customization as we showed in Lesson 6. So we will be talking about ROI Painter. We're going to see how you can use ROI Painter to do 2D and 3D segmentation, working in both the 2D and 3D views. We are going to give a very brief reference to a feature on the ROI tools palette called Interpolate. We're going to see a lot about the brush tool and the point and click tool. We're going to see some region tools for selecting regions at a time. We're also going to see the SmartGrid tool, which is another painting or another brush technique, but it uses something called superpixels. Now, the two data sets that we're using for today's lesson, one is the same data set we used in lesson 8. That was the data set on the mouse retina rod internal segments from Christopher Bleck's lab at NIH. And we will use that data set, and I'll show you where you can get that if you did not watch the lesson 8. We'll also use a data set called Backpack, and I'll show you where we're going to post that. So let's see if I can pull up a window so we can get this open. So if you are at Google, feel free to go to Dragonfly or type ORS Dragonfly. And here at ORS Dragonfly, if you go to the first link, should be the first link, under Learn Sample Datasets. So the dataset that we used yesterday in lesson 8 and the one we're using for lesson 9 is this one called Segmented Mouse Retina Cells. So grab that one. There'll be another one posted here today that is Backpack, and we'll load that up in a few minutes. We're going to start by loading the mouse retina cells. So let me pop over to Dragonfly. Here we are in Dragonfly 4.1. You should look just like this when you launch it if you made the customizations that we made in lesson 6. I'm going to start by going to this button over here on the right for import ORS objects, and I'm going to find the mouse retina, and we'll just let it import all of these objects so they're all checked. Click OK, let it import. All right, as a reminder, I'm going to double click here and show this attribution. So as a reminder, these data are rod internal segments from mouse retina. These are a FIBSEM, a reconstructed FIBSEM stack, and these come graciously from Christopher Bleck in NHLBI. All right, now the very first thing I'm going to do is I'm going to invert these data. So in imaging conventions, most imaging techniques show the presence of signal as high intensity, and high intensity is usually rendered as white. Biologists have, for decades now, often used an alternative convention where high intensity, which is wherever the stain went to in your biological sample, is rendered with low, or I should say high signal, wherever there is stain, has low intensity and is dark. So everywhere you see the membrane or the mitochondria or these ER-like membranes or the plasma membranes, that is where the signal is high, but as a matter of biological convention, it's being rendered as low. That's inconvenient for me, and it's inconvenient for the 3D rendering. So the first thing I'm going to do is I'm going to right-click on my image channel. I'm going to go to Modify and Transform, Invert. This is going to pull up this channel, this plugin or this control panel, and I'm going to tell it I want to invert the values, and I don't want to create a new data set because it's going to overwrite this data set. So it has inverted the values, and you see all where there is now signal is now white. Now this data set had a thin line around the edge. It was 1 pixel wide that was completely black, and so now there's a thin pixel line that is now white. So what I would like to do next is I'd like to crop that away, and I'm going to right click on my image channel. I'm going to go to Modify and Transform, and choose crop. Now this pulls up the crop dialog. I could interactively do this. I think we'll cover this quite a bit in a lesson in the image processing week, but for now I'm just going to crop in by 1 pixel in each dimension. So I'm going to set it 1 pixel on the 0 side of the x-axis and 1 pixel on the maximum side of the x-axis. So basically I'm going to reduce this from 1,450 to 2,449 in all cases. And I'm going to tell it to apply. And now that pixel has been cropped away. And I'm going to come back and I'm going to, and yeah, I'm good. So here's my data. You can see that it is inverted. And if I look at it in 3D now, you can see I can adjust the brightness and contrast using my standard methods. And now I can see the interesting details of the mitochondria, or if I change the contrast right, maybe the details of the cells. So this is a very useful way of visualizing where the signal has high intensity. So I recommend that. All right, now let's do some segmentation on this. So what we'll do is we'll start with some of the more basic tools in ROI Painter. I'm going to go over to the segment tab, and ROI Painter is this panel at the top where we see a dialog that looks like this. It's going to change, and you're going to see what I mean in a few minutes. In order for us to get started, we have to have, let's say, a canvas to paint on. So we have to have an ROI where we want to add certain pixels. So we can do, like we did in lesson 8, we can click New, and now this will allow me to create an ROI. So let's suppose I want to segment a mitochondrion. I can type mitochondrion, and now I have an ROI that is ready for me to paint the mitochondrion. Now I can go to any one of these views. Let's choose the view in the lower left-hand corner. You know, you can use the left and right mouse button to drag to pan and the middle mouse to zoom. So this is what's going to make us productive, is knowing these shortcut keys. Now I have a blank canvas for painting. So how are we going to label the pixels of a particular mitochondria? So as I mentioned, we're going to start with some crude tools. What I want you to do is, if you're in this window and now you come over into ROI Painter, we can choose 2D mode. And these are ways of adding signal or adding pixels to our mitochondrion label. And these will be 2D additions. You'll see what I mean. So the first I will do is choose the paintbrush. The paintbrush can either be a circular brush or a square brush. I'm going to choose the circular brush. Now, once I have selected the paintbrush and circular brush, then if I move my mouse in the view, you'll see it is now, the cursor is a circle. I also want to point out I do need to have an ROI selected so it knows when you start painting which ROI to add or remove. So got my ROI selected, I've got paintbrush circle turned on. If I position the mouse inside the view, we see this updated cursor. If I move the mouse, nothing happens. If I drag and I'm holding down the mouse button, nothing happens. If I hold down the control key on the left side of the keyboard, and now I drag the mouse, I can paint. So what I'm doing right now is I'm just doing this crude painting of pixels. So if I wanted to, I could paint. I can also hold down the shift key and drag to erase. So this is how you do this sort of simple painting and erasing. With this technique, you can hold down either the shift or the control and use the mouse wheel to make your brush bigger or smaller. So if I, painted a little crudely and then I wanted to use the erase button to come back and refine it, then you could do that. So we might do a little bit of painting like this. Now I have painted in only one slice, so this is slice 225. If I use the mouse wheel, I don't know if we talked about this, but the mouse wheel, if you release control, release shift, and you're not pushing any buttons or any keys, if you use the mouse wheel, you can scroll forward or backwards a few slices. So here I'm on 225. Let's go to slice, 230. And if I want to paint again on slice 230, I can. So I can paint a little bit here. Yeah, that's fine. I could go back maybe to slice 220 or 221 and paint something here. So I'm just dragging the mouse while holding down the control button. If I make any mistakes, I can, like that, I could hold down the shift button and do some erasing. And it's very easy when you're holding down control or shift to make that brush smaller or larger. And if you remember your keys for panning and zooming, you can get around quite easily. Now, if I double click and I zoom out and I hold down the T key, I can grab the crosshairs, put the crosshairs right here. And now if I hold down the middle mouse and drag, you can zoom in and you can see, oh, this is a very long mitochondrion. And these 3 views that we've done, these 3 slices, they are cross-sectional slices that look like this. Now, this is an XY view, and so this is an XY at like the Z equals 221, this is an XY at the Z equals 225, and this is the Z equals 230 slice. If you wanted to, you could take that painting that you've done and interpolate in Z. So if I wanted to, I could come over here. I've already done some painting. I could, with this ROI selected, it's very important that you always have the right ROI selected to get the behavior you want. With that ROI selected, I can come down to the operations and say I wish to interpolate along the Z axis and hit apply. And so now if I double click, you can see although I only painted on 3 slices, I have multiple slices selected. The interpolate workflow isn't really that user-friendly. You can do it if you're working on an individual object. You can see that it gave us the results we wanted, but you'll see that the way we normally do painting and you iterate, I think you're not gonna find it that useful for most workflows, but we can have a discussion offline about that if you like. So that was just very, very, very simple painting and interpolate. Now, let's do something more interesting. Now, let's suppose we wish to paint, but we wish to paint maybe only with the, maybe we wish to paint only on certain intensities at a time. So I'm going to click clear. And when I say only certain intensities, if I turn on the define range checkbox and now I drag this slider. So let's suppose I wasn't interested in segmenting the whole mitochondrion, but instead I just wanted the membrane, the plasma membrane and the cristae, but I didn't want all of I was going to say cytosol, but all the internal water-soluble components. Let's say I just wanted the membrane. If I set the threshold like this, and now I repeat, then you see that I can paint, and I'm getting just where the paintbrush is going, and only the pixels that are included in the red thresholding. So you can do something like this. You can paint multiple slices. Now, as I have mentioned, we are using a mode where we are painting with a paintbrush that is only painting in 2D. So I'm painting a 2D slice at a time. If I switch to 3D mode and I am in paintbrush, now when I paint, so I'm going to paint this slice, and then I'm going to scroll, and you see that the adjacent slices are also painted. That is because I am now painting with a spherical brush. So let's suppose I paint like this, and I paint like this, paint a few slices. Each time I'm painting not only the slice, but I'm painting slices above and below. So my paintbrush, when I add or when I subtract, now I'm holding down Shift key to subtract. When I paint, I'm painting not only this slice, but I'm painting an entire sphere at a time, a sphere of this radius. And so it's painting pixels from the above slice and the below slice. Now, if I double click and I come over here and I turn on this checkbox for 3D rendering of the mitochondrion, and then I come into 3D settings and say, let's hide everything that's not painted, you can see that I've traced out some 3D segmentation, and you can also see it over here. So again, if I, let's say, go to the edge where I haven't done as much painting and I start painting, you can see, if you watch either in the 3D view or over here, you can see that I'm painting quite a bit at a time. So if you have a system where it is amenable to painting with a 3D brush, then you'll be far more productive than painting with a 2D brush because you're painting multiple pixels at a time. And so this is true of the painting and the erasing. So whether you're holding down Control to paint or Shift to erase, it is going to erase with a spherical brush. So that is the method for using the paintbrush in 2D and using the paintbrush in 2D with define range turned on, but also painting in 3D with define range turned on. Now, we don't have to use define range. I could just paint like this, and now we are painting all the pixels. I could come over here and paint in this view. So there are different ways of doing this. Whether you use define range or not, you can still do the 3D paintbrush technique. So that is useful. So all we have done is we've looked at the brush, and we've only done it in these 2D views, but we've either used a 3D mode or a 2D mode. Now, this behavior is also available from a square brush. Not really helpful for this sort of data set, but you can paint and erase with a square brush. What I would like to do is also point out that while you can paint on these slices, you can also paint on oblique slices. So if I were looking at this and I wanted to look at it from another slice, there's a mode here called walk, and I could click here and drag, and now I'm going to look at an oblique slice of that same mitochondrion, and I can go any oblique slice I want. We also saw in earlier lessons that you can grab these crosshairs and change the different oblique slices. So I can once again go back to the 3D paintbrush and I can paint in an oblique slice. So you don't have to paint in one of the orthogonal slices. You've got lots and lots of freedom for what view you're looking at when you're painting. All right, so that is the paintbrush in a 2D slice, either using 2D mode or 3D mode with square and circle brush and with define range turned on. Now we will go, I'm going to hit the reset reset button here on the manipulate panel just to reset these views. I'm also going to clear my segmentation so we can look at some other methods. Now we're going to go back to the 2D mode. Remember, the 2D mode adds or removes segmentation only on the currently viewed slice, and this would be whether it's an orthogonal slice or an oblique slice. And all we've looked at in the 2D mode is the paintbrush, but now let's look at the region tools. So if you wanted to add a particular region, you could just control drag to add or shift drag to erase. So you are adding all the pixels inside a rectangle, or it could be, you could use sort of a lasso, and this freehand tool is kind of like a lasso. And so you could add, or if I hold down shift, we could remove. So you can use these region tools in 2D and they have no effect on the adjoining slices because it is just a 2D addition or subtraction. So all of the region tools work the same way. That is, they allow you to create a 2D region. So this is a polygon tool. We saw the freehand, or what looks like a lasso tool. There's also an ellipse tool for adding or erasing. Now, that covers the region tools, except I should say that they also have the same behavior that you can use the define range. So if I do a clear, and now I say I want to, let's use the lasso tool, and I want to add all of these pixels. Okay, now everything inside the lasso that met that define range criterion is now added. So it's only a 2D addition or subtraction, but it's very, very powerful for adding a lot of pixels very selectively, very quickly. So that covers the region tools on a 2D slice. Now, there are 3 other buttons here we'll look at very quickly. So I'm going to turn off define range for just a minute. One button just allows you to trace out a path, which is basically a single pixel long. So this is not like a region tool. It's not going to fill in the contour. It's just going to add a single pixel thick. So sometimes if you're trying to trace out a single line, it can be useful. Now, again, control drag to add, shift drag to remove. And so you see it removes the bit of a path. So that is the tool for path addition and subtraction. I'm going to hit clear again. So there are 2 tools left on this palette. One is the SmartGrid tool and one is the Snap tool. The Snap tool is sort of a region growing tool in 2D. So if I turn on the Snap tool, it's going to evaluate the current selected image, or really the image that is defined right here, and it's going to look at the gradients in that image based on the image intensities, and it's going to allow you to grow a selection in or out. So I can click and drag, and it will drag out. Now, the initial selection, I think, is based on how big your cursor is. So it's not going to be so good for these biological data, obviously, but you can use this sometimes when you need to do sort of a region growing tool. So this is an option, but again, it's only working in 2D. Now, the last tool I want to show here is the SmartGrid, and I like this tool a lot. So as soon as you click the button, it is going to show some parameters here. What image is it evaluating? And it says a grid size and a sigma. I'm going to suggest that just as a default, maybe you want to pop that up to 64 by 64 and remove the sigma, and you'll play with different data sets where you do want a sigma. It applies some smoothing. Now, what has happened is this has decomposed our image into a bunch of, let's say, puzzle pieces. And every time I zoom or pan, it creates new puzzle pieces. What this allows me to do is I can use this paintbrush sort of tool, and it paints the entire puzzle piece, or what some people call superpixels. It paints the entire superpixel rather than you having to paint individual pixels. So you can do this sort of technique, and if you zoom and pan, it'll regrid the image, and so you can erase superpixels and add superpixels, scroll through to another slice and start adding superpixels. So this can be an effective way of segmenting structures. Now I can erase. We can also look at an operation down here. There is an operation called fill inner areas. So if I did a fill inner areas on this axis, it'll go through every slice. And if it has pixels like this that are not painted, that are surrounded by painted pixels, you can do, let's click the undo button. I wanted to click this, apply interpolation. I did not want to do that. I'll click undo again. I wanted to click here. Where is it? fill inner areas in Z. There we are. And you see the effect. All right, so we can scroll through. Now, if I, if my superpixel did not do a great job, then I can always, let's go to a slice that has some painting on it. I lost track of where I was. Scroll, 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 go back. Oh, maybe I hit clear. I don't know, I wasn't paying attention. Let's suppose I did paint something and something like this, and I got too much signal painted. Of course, I could always switch back to the regular paintbrush mode and clean up my signal. So I could always come back to paintbrush and turn on a circular brush. And now I can hold down the shift. Well, let's make it a little bigger. Hold down the shift key and erase. Now, that's superpixel, but you can also, when you zoom out, you'll see that the pixel pieces are larger. Effectively, it's creating 64 by 64 pixel pieces on the entire screen. So if you have a very big screen, the puzzle pieces will be very, very large, cover lots of pixels. If you zoom in, they'll be smaller. What this means is I can zoom out if I want to try and get, the cells. So if I want to do this, this can be a very fast way of doing segmentation on 2D slices. Just like the other tools, if I go to some oblique slice, it still works. You can still grid the image. Now there are sort of these interpolation artifacts you may notice. It looks like it's not painting. That's just the way the data is being sliced. It is painting everywhere, and it's just an artifact of what a discrete ROI sample looks like when you're looking at it from different angles. So you can use these tools. All right, so we've looked at all the tools on the 2D palette, and these are all tools that are working. I'm operating in a 2D slice. That is, I'm not over here painting. I'm in one of these views, and so these are my choices. I've got these 2D tools. Now we also have 3D tools. We're not going to look at the point and click right now. We're going to wait till we get to the backpack to look at the point and click tool. But we did see that we can do a 3D paintbrush. Okay. So that covers just about everything I think we're going to show on the mitochondria example with the painter tools. Now what I'm going to do is there is one more thing I want to show you, but I think we'll come back to it. So I'm going to, let's remove this mitochondrion ROI, and I'm going to hide everything for now. I'm going to import my backpack data set. So I'm going to come to backpack and click OK. I'm going to turn on the backpack, turn on the attribution. I'm going to hit this reset button here. Now, just so you can see, this is a CT scan of a backpack with various contents. This was publicly shared on Volviz. This was I think it was an open source 3D or image viewer toolkit. The website seems to no longer be active, but it was publicly shared, and that's why we have it in our archive. And so that'll go up later today on the shared data sets that you can get on the Dragonfly website. Okay, so this is a backpack. If I double click, you can see that it's, you can see the bed of the CT scanner. You can see a whole bunch of content. You can't really see the backpack mesh because it's so low attenuation and so low contrast. Now, we're going to use this example to look at more of the painting and ROI painter tools that exist when you're operating from a 3D view. So everything we've done so far, we've painted and interacted in the 2D views, but we can also paint and interact in the 3D view. I'm going to start by going to define range. I think I'm going to select the backpack, choose define range, and I'm going to hit the upper Otsu, and I'm going to add this to a new ROI. So I've got this new ROI. If I turn it on in 3D, you see it's selecting a lot of the high intensity pixels. So just so you see what happened. So if I adjust the brightness and contrast, this is what the image looks like. And the Otsu thresholding gave us all these pixels that are red. And by clicking add, they were added to this magenta ROI. So I could rename this high intensity of the backpack, for example. Okay. Now we have this ROI, we have this selection, and we can do different things with it. One of the things I'm going to show you is, let's suppose we were not interested in one of these objects and we wanted to remove one of those objects. There are different ways of removing discrete objects. So if let's say I wanted to remove this object right here, I could come in here in ROI Painter and I could choose the point and click tool. And the point and click tool says, what signal am I supposed to be evaluating? Well, I want it to evaluate the signal of the high intensity segmentation because I would like it to remove this segmented object, for example. I can, with the point and click tool, I can come down here and I can select this and select my high intensity. And now I can come over here and hold down the Shift key and remove, and now that's been removed. So if I hit undo, we can see where it was in 3D. And it's this guy right here. So again, if I hold down the Shift key and remove, it's unpainted. So you can remove individual objects. So we'll look at this in the mitochondria again as an example. If you've got 25 mitochondria segmented and you want to remove one at a time, you could do that. So this is using the point and click tool to remove different, let's say, islands of segmentation. Now, I'll click the undo and we'll go back. Now, let's suppose I wanted to remove small objects, or I wanted to extract just a large object. So let me show you what I mean. So one thing I could do is I could right-click here on high intensity, and I could go to Refine Region of Interest. Process Islands, we're going to look at this more in Lesson 10. Process Islands is very powerful. Let's suppose I wanted to process this and give me just the largest object, for example. If I go to Refine Region of Interest, Process Islands, and I say Isolate, and it says nth first biggest, so isolate 6 connected, nth first biggest. If I click this and I say I just want the one biggest object and hit OK, then it is pretty much gotten rid of everything except this. So all of this is all connected into one big object. Now, part of that is because a lot of it's connected to this thing at the bottom, and it's just not a very clean segmentation. Now, if I hit undo, you'll see all the other objects come back. You could also get rid of the one biggest object. So if I did a right click here, and I said Refine Region of Interest, Process Islands, remove one biggest object, or the 2 biggest objects or whatnot. I click OK, and now it's removed. And so if we adjust our contrast a little bit, you can see that now we've got a lot of the smaller objects that are still there. So let's suppose that we did not do that. So I hit undo. And maybe we're interested in some of these objects, or maybe we just wanted to use some 3D techniques for refining what is painted. Now, we saw with the mitochondria and the rod internal segments from the mouse data that I can click in these views and operate in these views. Now let's suppose we want to use some tools in the 3D view. If I choose, for example, let's go with this tool. This is a region tool, and I'm in the 3D view. And let's suppose I want to remove certain signal. I'm going to leave this selected as high intensity for now. Let's suppose I wanted to remove all of these pixels that are currently labeled high intensity, or remove some of them. I can hold down Shift and drag, and what it'll do is everywhere I dragged in the 3D view that there was signal, it will remove it. So if I zoom out a little bit, and let's adjust the brightness and contrast a little bit. Now, if I want to remove this, I could, hold down Shift and do something like this, and now all of those pixels are removed. So you can do that sort of thing. Again, I'm going to come over here under high intensity and adjust my on-screen rendering so you can see that this is what is segmented, and here's the rest of the data. So if I turn down the highlight, here's everything that is segmented. So this can be very, very powerful, obviously. Let's suppose I'm interested in, I don't know, in this can right here. Then maybe what I'll do is I will, and I'm holding down the T key as I drag the mouse because I am still in this, oh, I just clicked the R key, so I'm in ruler. I was in this state, which is the freehand state, and when I hold down the T key, it rotates. Now, what I can do is I could use this lasso tool while holding down Shift to remove some of these pixels, and then I could try and extract out, the largest 2 or 3 objects if I wanted to get this paint can, for example. So we could also use object analysis. We saw that of the objects analysis, you can process each object individually, but maybe in the painting process, you want to remove or isolate objects. So those are options. So we saw we can remove and isolate. So I could ask it now for, let's say I ask it for the 3 biggest objects. If I right click and go to Refine Regions of Interest, Process Islands, and I say isolate the 3 biggest objects. Okay, so now I have all of this that is somehow connected in this object. And well, it would be very, here, object 1, object 2, object 3. So so this is clearly the biggest object, and this is the second biggest object, and this is the third biggest object. Now, maybe I just want to forget about that process islands, and I just want to, use my freehand tool and erase a bunch of this stuff. Okay, holding down Shift, and all that's removed. Now, clearly the object that I want is the biggest object, so I could right click and do Process Island, isolate the one biggest object, and there. Now, you can also, while you're there, you could just right click and say process islands, remove everything that is, say, smaller than 300 pixels. So you can sort by a rank order, or you could sort and just remove things that don't meet your minimum or maximum pixel count. So that's quite handy. So here I have this, and we've looked only at this tool, but let me select my region of interest. We've looked only at the freehand tool, but the other region tools work as well. So if I, for example, if I wanted to use a rectangle tool so I could get a nice straight line, it is going to be aligned with your monitor, shall I say. So if I use this and I hold down Shift and drag, then it's going to erase all of those pixels. So you can do some things like that. Now, you can also use the paintbrush in 3D. Now, let's talk about this for a minute. We saw that when we're on the paintbrush mode, if I'm in the 2D view, if I have a circular paintbrush, you can see the pixel size, the brush size, and you can make it smaller or bigger by dragging the mouse wheel. It also works in the 3D view, but it currently does not. There's nothing in Dragonfly that shows you the size of the brush, so you need to look at it in the 2D view to know the size of the brush. Now, we can paint, and we would like to paint based on the on-screen pixel transparency. Now, let me explain what I mean. Instead of painting based on what is already part of the high intensity ROI, I'm going to choose to paint based on the backpack. Now, if I have something where the contrast looks like this, and I start dragging and painting, I'm painting all of these pixels, which not so useful. I'm going to click the undo button. It's going to undo everything in that one big paint stroke. Now that I've reduced the contrast, if I put my cursor in exactly the same spot and I paint, it's only going to paint if I'm intersecting some pixels that are not transparent. This means that if I wanted to paint this can, for example, I could zoom in and I could just start dragging and painting. And I can use the track mode. I hold down T to rotate. So you can paint or you can erase with Control and Shift, just as before. So let's go back and make the brush a little bit smaller and then come back over here, double click. If I want to clean this up, I can hold down the erase key and do a little bit of erasing. Oh, I'm holding down the add key. So you can use the paintbrush in the 3D mode. You can also use the point and click in 3D mode. So if we have something, here, let's do it this way. I'm going to adjust the brightness and contrast. So all of this method where you're using this brush and also this point and click we're going to use, it is sensitive to the brightness and contrast. So it's only going to respond to pixels that are not transparent. So if I go to point and click mode, let's suppose I'm interested in adding this, I could go to point and click mode and say, I want you to look at all the pixels in the 3D view in the backpack that are not transparent. And so now when I hit Control, it will add all of that object. If I want to add each of these little bolts, okay, it's a little noisy because there's lots of these pixels that are not quite as transparent. If I remove those, here, you remove them. Maybe I want to change the brightness and contrast a little bit so I get a cleaner segmentation. Now when I do the point and click, still pretty messy. There is something we hadn't looked at yet. We'll look at tomorrow at morphological operators that could help clean that up, like with a 3D opening we might run. It's going to run on all the data, not just on those, so it might actually be a little bit slow, but you could do a 3D opening and see if it cleaned up some of that. It did. Okay, so we've looked at point and click in the 3D view, we've looked at the paintbrush in the 3D view, and we've looked at these tools in the 3D view. I think that's probably almost everything we're going to cover. I did want to show one more thing on the mitochondria. So in this case, I have my 3D image channel of the mitochondria, and I have this segmentation. This is a multi-ROI. I'm going to right-click and choose an ROI, make it a new ROI from it. So with this ROI, I have all of these mitochondria, and I wanted to point out, I said before that if you use the point and click mode, the point and click tool, which you can use in a 2D view, so I can select my ROI and choose 3D mode, point and click. So if I come down here and I hold down the Shift key, it will remove that entire mitochondrion, and it has to look through the entire, I selected backpack instead of mitochondria. So it's actually looking through the whole data set and making a decision based on backpack. That's okay. we'll wait for it to come back, and then we'll hit the undo button. Yeah, it looks like it. Well, hit the undo. Whew. All right, we're back again. Sorry about that. So if I wish to use this and I wish for it to operate based on this mitochondrion ROI, I can choose mitochondrion. And now if I hold down the shift, it's going to erase that entire mitochondrion. But I can also do this in 3D. So if I wanted to remove, for example, these mitochondria, well, let's say these little fragments, I could just hold down shift and remove these guys. So this is a nice way of editing an ROI. So there is one behavior of the point and click when you're doing on an image that I didn't really show, and there's just not really time for it. That gives us a lot to look at and think about. Maybe we should have another follow-up lesson on ROI Painter since there's so much here, but I'm just going to remove some of these because I feel like pruning my data. So that gives you a lot. I know this is not a very organized lesson. It's hard to show all of these tools and what they're useful for because with some data sets you need some tools, and with other data sets you need other tools. So it's hard to sort of just pick one or two data sets and show the utility of all of them. But it does give you a really good introduction to the different tools of ROI Painter that affect either 2D additions and subtractions that you can do in the 2D view, or 3D additions and subtractions that you can do in the 3D view. With that, I'm going to turn to questions and answers. So I see we already have some questions in the queue. So the first question is, Carlos says, are there tools to tackle the metal artifacts in the images? So no, the streak artifacts you're seeing in this, of course, are well, we'll just call them streak artifacts now, that are due to the metal and the high attenuation and it's the limitation of the beam energy of the CT scan. We do not have any tutorials planned on how you would deal with that. I don't know that we would have a good lesson on that. So the short answer is no. The long answer is that's something that should be solved in the reconstruction algorithm, and it's probably still a year out before we have our advanced CT reconstructor that would have solutions for that. So I don't think we're going to have a good solution on that in the near term. Next question is, can you segment by a combination of shape and color? I think this is a question from just before the lesson started. You can segment based on shape features and based on intensity. And the intensity could come from a red color channel and a blue color channel and a green color channel. You could do that with the segmentation trainer or the deep training tool, but that's not part of ROI Painter, so we're not covering that today. Next question is, can you segment a slice or several slices in all three directions and use Interpolate to interpolate in 3D? That's a great question. The interpolation in 3D can happen, but it does not happen with ROI Painter. It happens with a whole other tool in Dragonfly called Active Contour. It allows you to draw a contour around it in any slice and any orientation, and you can have many oriented contours. They can be parallel or perpendicular or orthogonal, it doesn't matter. And then you can do 3D interpolation on the contour. However, that's beyond the scope of today's lesson. So you could look at the active contour in the help, and I think we even have a video online, but we could dedicate a tutorial on that. Next question, can you interpolate between contour slices on multiple planes? Yes, I think we did that. In the beginning, we segmented on slice like 421, 425, and 430, and did interpolation. Okay, next question. Are the superpixels, do they work within a defined range? No, I don't think the superpixel responds to the defined range checkbox. Next question, are the ROI Painter tools comparable to similar tools in other packages like Amira and Aviso in the way they operate? Well, you do have, as you see here, you can paint and you can subtract. I think in Dragonfly, it's far easier to change the paintbrush and to add and subtract because you're using the mouse and holding down a key instead of coming over and clicking a plus button or a minus button. We think we've designed it so it's easier. It is quite different. We don't use the buffer concept, at least right now. We don't have a buffer concept the way Amira, Aviso, you don't paint on an ROI, you paint in a buffer and then add or subtract from an ROI. The other really big difference is in Dragonfly, you can paint on any oriented slice. So if seeing the right contrast, you need to change to an oblique plane, you can do that in Dragonfly, whereas the last time I used Amira or Aviso, you were restricted to working on just the orthogonal slices. And if you needed a different orientation, you have to resample the data. So far more flexibility in Dragonfly. Next question, is it possible to use Dragonfly functions in Python? Yes, everything in Dragonfly is available in Python. And if you go to Dragonfly and you go to developer, let's see, I'm looking for the developer documentation here under help, Dragonfly developer documentation. It will open your web browser to, I think in this Zoom session, it's not going to load the page for me because it's maybe protected. But what you would do is at the, actually you could just go to dev.theobjects.com and you'll land, oh, I'm sorry, my mistake. If you go to the objects, or if you go to the Dragonfly website and you go to learn, you can choose developer documentation. And here you choose which version of Dragonfly. So you can choose Dragonfly 4.1. And there are thousands of lines of documentation on all of the different classes. So for example, if you choose channel here, this is just the functions that you can operate on an image channel. You can control this from a Python script. You can write your own Python stuff in Dragonfly, or for that matter, if you're in Dragonfly, you can pop open a Python console directly just by going to tools, going to the bottom and choosing Python console. And now if you're right here, then you could always get to work on anything. Either if you want to work on a segmentation, you can define a reference to the segmentation, say my ROI, come over here, get this. And now you have my ROI and you have all of its available functions. So you can do the same thing with image channels and everything else. So long answer, but there are tons of things you can do in Python with Dragonfly. Currently, we do not have any tutorials planned on that. We could spend a couple of weeks just teaching how to do things in Python with Dragonfly. Next question, when you paint in 3D by selecting the data set, is there a way to indicate what the intensity cutoff should be? Well, that's something I didn't show. The point and click tool is actually sensitive to define range. So you could turn on define range for that data set and set an intensity interval and then use point and click, and it will only extend based on pixels that are connected to the pixel you click on that fit within that range. So define range also modulates the behavior of point and click. Let's take two more questions. Is the high intensity region blocking or letting the X-ray pass through? For example, metal particles in a polymer. I'm sorry, the question seems to have disappeared. Maybe oh, there it goes. Metal particles in a polymer. Is the metal or polymer brighter by default after Zeiss micro CT scanning? Sorry, Marshall. Maybe we'll have to take this question offline. The metal is the bright. So where you have anything that has high X-ray attenuation, it will be bright. And if you have this phenomenon known as photon starvation, where not enough pixels are going through, it can cause this really bad streaking artifact. Next question. So ROI Painter in 3D treats transparency as the defined range of 2D. Yeah, that's one way of thinking about it. So when you adjust the brightness and contrast, you are doing exactly that. You're using it's like you're using define range, but it's an on-screen visual feedback just based on pixels that are not transparent are the only ones that can be selected. And if time allows, can you briefly show the other behavior of point and click? Maybe if you tune in tomorrow, I can do it before the lesson tomorrow. I can show you the point and click behavior. I think I would be very productive. I can do that. Tune in tomorrow, 10 minutes early, and I'll answer that question. All right. Okay. That's we're way over time. Thank you all for attending. Remember, lesson 10 will be on advanced segmentation. We'll look at some mathematical morphology operations. We'll also look at how to identify we'll look at union and intersection and logical subtraction, lots of operations where you combine ROIs and shapes. We'll look at process islands some more. If you need to identify objects that are maybe touching or objects that are touching the face of another object. Anyway, all sorts of more things, so tune in for that lesson. Thank you all for your time. Stay healthy. Good luck. Have fun playing with Dragonfly, and everybody take care.